So this whole section is about factoring quadratic trinomials. And we had that long process, but we learned that shortcut. When the a value is 1, there's that beautiful shortcut where you simply go, what times what is the c value that if you add together is the b value? And you could make a list if you want, and you just put it right into your answer format. So once again, because the a value is 1, you could set it up already in your answer format. T right here and t right there. Once again, because t squared, if there's a 1 for a, t times t gets you t squared. Now you could already see how it's going to be a problem later. Like let's say you had an 8 in front. Then it wouldn't be t times t is 8t squared. It might be a 4t times 2t. It might be a 8t times 1t. Or, so there's different possibilities. So that's when we have to use the long process that we'll be reviewing more. But right now on this homework, on this practice, on this video, we're just going to be simply practicing the shortcut, which is, there it is, what times what gives you C, that if you combine gives you B, and you might want to make a list, right? You might want to make a list. So for example, if you don't see it right off the bat, what times what is C, positive 12, that if you add together gives you positive 8. Anybody see it already? 6 and 2, that's right. So you just put positive 6 in here, positive 2 right there, you're done. That's it. That is it. All you do is think what times what is C, that if you combine together is B. 6 and 2. Now, like I said, if you're having a rough time thinking about this, grab a calculator and start making a list. Like, how could you get 12? Well, you could have 1 times 12, make a list. 2 times 6, 3 times 4, 5, 6. No, that's it. Those are all the 3 possible ways of combining or of multiplying to give you 12. And then you could look at the list and be, okay, if I add these guys together, does it give me 8? No, it doesn't. That gives me 13. If I add these guys together, does it give me 8? Yes, it is. So this is the pair of numbers that I want. I plug in the 2 right there, plug in the 6 over there, and you're done. By the way, it doesn't matter if you plug in the 2 right here or over here. So you could have them switched. It doesn't really matter, as long as you have the right pair of numbers, 2 and 6. Okay? So shortcut. We're just practicing shortcut. Later on, we'll go back and review that multi-step process that involved factoring by grouping. But right here on this one, just shortcut. So we're just going to set it up. Parenthesis, 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 parenthesis. N. What times what is 12? That if I add together, 7. 3 and 4. Positive 3, positive 4. Okay, cool. Moving on. Check it out. Number 3. What times what? Or let me set it up though. Set it up. P. P. Okay, that wasn't funny. Sorry. What times what is 20? That if you add together is 9. 5 and 4. Positive 5, positive 4. And it doesn't matter if you say 5 and 4 or 4 and 5. That's it. You're done. This is like, that's it. I mean, let's go to something. I mean, at least this one has different signs. Yeah. Let's go to number 9. So let's set up the parentheses. R. What times what is negative 12 that if I add together is positive 4?
Positive 6 and negative 2.
Positive 6 and negative 2. And we're done. Now, let's actually go through the motions here. Let's pretend that, I don't know, I don't really know which 2 numbers. Okay, make a list, right? Again, the shortcut is what times what is your C value. So your C value is negative 12. How could you get negative 12? Well, it could be negative 1 times 12, or it could be negative 2 times 6, or it could be negative 3 times 4. And then you just go through and add them. Combine them. I should say combine, not add. So negative 1 and 12, that gives me 11 if I combine it. This middle term is not 11. This one is the one that if I combine negative 2 plus 6, if I combine it, that gives me positive 4. So all I need, this is my correct pair of numbers. Just plug it into your answer format and you're done. Now sometimes you'll have the right pair of numbers, but you might have the wrong signs. You just switch the signs. See if we could find one of those here. 15. Sure, why not? Okay. So let's set up the factored form. T right here, T right there. And now we're going to think, what times what is 56 that if I add together is negative 15? Well, let's just make a list. How could you get 56? 1 times 56, 2 times, what's 56? 3 times something give us 56? 56 on the calculator divided by 3?
No.
No? Doesn't work. Okay. How about 4 times something give us 56? 4 times 14, that works. 5 times something? No. 6 times something? No. 7. 7 times 8 gets us 56. And which pair of numbers, obviously this didn't work, but which pair of numbers combines together to give us negative 15? Negative 7, negative 8. So just to go through the motions, 7 and 8 gives us 15. However, this is a negative 15. So you know you have the right numbers, you just have the wrong signs. So in reality, it's going to be a negative 7 and a negative 8. All we do is change the signs. Because negative 7 times negative 8 really does give us positive 56. And if I combine them together, it really does give us negative 15. So it's going to be a negative 7 and a negative 8. And that's factored form. It's that simple. So you're probably thinking, why do I want to change a quadratic trinomial to 2 binomials that I'm multiplying? It's great to be able to do that because when you're solving equations and your equation is equal to 0, then you'll be able to apply the zero product property. Check out number 18 here, for example. You notice that this is a quadratic trinomial. Let's see if we could factor. So let's set it up. It's still equal to 0. And what times what is positive 12 that if you add together is negative 7? Now, if you don't know, let's just write it out. 1 times 12 gives you 12. 2 times 6 gives you 12. 3 times 4 gives you 12. That's about it. Which pair of numbers gives us a negative 7? The 3 and 4. However, it's not negative, that's positive. 3 plus 4 is positive 7. And we know we want it to be a negative 7. So we have the right numbers, we just have the wrong signs. Oh, by the way, I forgot to put the variable b right here and b right there. So these signs are going to change to a negative 3 and a negative 4. So it's really going to be a negative 3 in there and a negative 4 in there. Now, the reason why I want to be able to factor it is because when it's equal to 0, now we could use the zero product property. The zero product property says if I have something times something and it equals 0, this first something could be equal to 0, or this second something could be equal to 0. So what ends up happening with the zero product property is you take two binomials that you're multiplying together and you could split them, set them each equal to 0. So you had a complicated equation at the start, and now we have two simple one-step equations. And of course you solve plus 3, b equals 3. That's one answer. Plus 4, b equals 4 as another answer. So you actually get two answers for this one, number 18. Once again, we factor so we could get something times something equals 0. If I don't have an equal 0 here, that's pointless. You can't split it unless it's equal to 0. That's called the zero product property. It's called zero product property for a reason, because it has to be equal to 0. Okay, so let's say you had, let's say originally you had a negative 12 right here, yeah? If you had a negative 12, you'd have to subtract it, or do the opposite, add 12 over here to both sides so you can make it equal 0. So sometimes you have to make it equal 0. Jump to the last one, number 26. Right there, obviously it's not equal to 0. It says equals 11w. So it's asking us to solve. And yeah, the first thought you should have is, could I get w by itself on one side? But these are w squares. These are regular w's. You can't really combine them, right? So even if you're supposed to do this anyway. You're supposed to subtract 11w. Subtract 11w, but the problem is you can't subtract 11w from w squared, so you're just going to rewrite it. It's going to be w squared minus 11w plus 30 equals 0. See how I made that equal to 0? Now I could think, okay, because it's equal to 0, now I could factor, split, and solve using the zero product property. So let's factor first, parentheses. Because of the shortcut, we could put a w here and a w there and just think, what times what is the last number that if I combine together gives me the middle value, negative 11. So you might want to make a list. I always make lists. How could we get 30? Well, it could be 1 times 30, or it could be 2 times 15, or it could be 3 times 10. Now, you could even start thinking, if I add 1 and 30 together, I get 31. Is this middle term 31? No. 2 and 15, that's 17. Is this middle term 17? No. 3 and 10, that's 13. Is this middle term 13? No. So far, none of these pairs work. Let's keep going. 4 times something, give me 30? No. How about 5 times something? 5 times 6, there you go. So 5 times 6. Now, if I add 5 and 6 together, does that give me negative 11? It gives us positive 11. So we have the right numbers, we just have the wrong signs. So let's change this to a negative 5 and a negative 6. So you're going to have w minus 5 in there, w minus 6, and that's your factored form. And now we're able to split it and say, okay, this guy times this guy equals 0. So this one could be equal to 0, this one could be equal to 0. So we now have two simple equations. Let's solve both. If you add 5 to both sides, you're going to get w equals positive 5. And over here, if you add 6 to both sides, you're going to get w equals positive 6, and you get two answers. So that is the whole purpose of factoring quadratic trinomials. So you could end up with something times something, hopefully equal to 0, and then you could split them and set them each equal to 0 and solve. Now sometimes you're not going to be able to factor, guys, and that's totally fine. Like if I told you x squared minus 2x minus 12, and I tell you factor it. Now you're probably thinking, oh, well, the a value is 1, so I could just jump to my shortcut. Yeah, that's a great first step, jump to your shortcut. And now you're thinking, what times what is negative 12 that if I add together is negative 2? What times what is the last one that if I add together is the middle one, that I combine together is the middle one? Now you might make a list, negative 1 times 12, negative 2 times 6, negative 3 times 4, and then you'll realize that none of these work. If you add these guys, you get 11, not 2. If you add these guys, you get 4, not 2. If you add these guys, you get 1, not 2. Or not negative 2 for that matter. So none of these work. So if I did say factor, like let's say these were the instructions, and it will happen, and you're trying to do this, and you realize that none of these work, then what do you say? You say not factorable. And what does that really mean, not factorable? That means that you're not able to factor. Not factorable. So continue working on this worksheet as more practice, and then tomorrow we'll pick up with quadratic trinomials that don't have the a value of 1. Again, all of these have the a value of 1, which allow you to jump to your format, variable here, variable there. But tomorrow we're going to have a different number other than 1, and we're going to have to do that long process, right? So enjoy today's worksheet because it's so easy.